It's 2 a.m. Your phone won't stop buzzing. The order service is down. Customers literally cannot place orders. And now, the payment service is throwing errors too. Within minutes, the entire engineering team is awake and piling into a production war room. 2 hours of digging, logs, dashboards, stack traces. And then you find it. And it makes no sense. The order team didn't deploy anything. The payment team didn't deploy anything. The thing that took down 3 services at 2 a.m.? The user team renamed one column in a database. One column. 3 services dead. How is that even possible? The answer is a pattern almost every microservices team uses on day 1. It's called the shared database pattern. And here's the twist. It's not stupid. It feels brilliant when you start. That's exactly why it's so dangerous. Okay, let's build something together. An e-commerce app. Nothing fancy. We've got 3 services. A user service, an order service, and a payment service. 3 clean little microservices. Now here's the decision every team faces on day 1. Do we give each service its own database? And honestly, that feels like overkill right now. One database server, a handful of tables. Spinning up 3 separate databases just feels like work for no reason. So we do the obvious thing. We share one database. All 3 services point at the same place. Inside it, a users table, an orders table, a payments table. Every service can read and write whatever it needs whenever it needs it. And I want to be clear, this is fast. It's simple. It just works. For a small app, this genuinely feels like the right call. Because right now, it is. Hold on to that feeling. Because that feeling is the trap. Let's be fair to the shared database. It didn't get popular by accident. It solves real problems, and it solves them beautifully. Let me show you 4 reasons teams fall in love with it. Benefit 1. Data is just there. Say the order service needs customer info. With the shared database, it just queries the user's table. No API call. No network hop. The data is right there, instantly. It feels like cheating. Benefit 2. Joins. Say you want order details and customer details in a single response. You write one join query, and the database does all the heavy lifting for you. One query, one response, done. Benefit 3. ACID transactions. This one's big. A customer places an order. You need to create the order and create a payment record. With a shared database, both of those happen inside a single transaction. And if anything fails halfway through, roll back. The whole thing unhappens. Your data is never left in some weird, half-broken state. It just stays consistent. Benefit 4. Reporting is trivial. Management asks, "What was our revenue this month?" All your data lives in one place, so generating that report is easy. So if this pattern is this good, why does every senior engineer call it an anti-pattern? Let's ruin the party. Here's what changes. Nothing about the database. The company changes. You grow. You hire. And now different teams own different services. The user team owns the user service. The order team owns orders. The payment team owns payments. And the moment that happens, the cracks start to show. Problem 1. Tight coupling. Remember how the order service reads straight from the user's table? They built their code around your schema. Now the user team decides to clean things up. Rename a column. From their seat, it's a harmless little refactor. And the order service falls over. A change by one team just broke a completely different team's service. Problem 2. Nobody actually owns anything. Who owns the users table? Everyone reads it. Everyone depends on it. So when it breaks at 2 a.m., who's responsible? Nobody knows. Ownership just dissolves. Problem 3. Deployments get tangled together. The order team is ready to ship, but the payment team is modifying that same database. So now, the order team waits. You built separate services so teams could deploy independently. And now, they can't. Problem 4. The distributed monolith. This is the scary one. You look at your diagram and you see microservices. But underneath, every service leans on the same database. Every schema change ripples across teams. Everything is coupled to everything. That's not microservices. That's a distributed monolith. The worst of both worlds. Let's make this concrete, because this is exactly how that 2 a.m. call actually happens. The user team decides to rename a column. Phone_number becomes mobile_number. Reasonable. Cleaner. They test their service. Green across the board. Deploy succeeds. Everyone goes home. A few minutes later, the pager goes off. The order service is failing. Then payment. Then the nightly reporting jobs start dying, one by one. Why? Because every one of them was reading phone_number, a column that no longer exists. One tiny, sensible, well-tested change, and it set off a chain reaction across the entire system. That's the 2 a.m. phone call. That's the thing nobody deployed. Now here's where I have to push back on the internet a little. A shared database is not automatically wrong. Small app, small team, low traffic, simple requirements. A shared database can be completely reasonable. In fact, forcing separate databases too early will bury you in complexity you didn't need yet. The pattern doesn't fail because it's bad. It fails when you outgrow it. The danger shows up the moment your org gets big enough that teams need to move independently. That's the inflection point. That's when the costs quietly overtake the benefits. So let's bring it home. The shared database pattern gives you easy joins, easy transactions, simple reporting, and fast early development. Real benefits. But as you scale, it hands you the bill. Tight coupling, tangled deployments, fuzzy ownership, and eventually that distributed monolith. And once a team feels that pain, they all end up asking the same question. What if every service owned its own database? Would that finally kill the coupling problem? The answer is yes. It absolutely would. But it cracks open a whole new box of problems, and some of them are genuinely hard. That's exactly what we're tackling next. The database per service pattern. If this made the shared database click for you, subscribe. I'll see you in the next one.